the universe. It feels endless. Stars, galaxies, cycles that last billions of years. But scientists do not believe it will last forever. One day, everything will end. Will it be quiet, or will it be a cosmic disaster? Physicists study the motion of celestial bodies, the distribution of energy, and the rate of cosmic expansion to understand the universe's fate. What we know today opens the door to possible endings. Some are dark and terrifying, while others are almost poetic in their silence. In this video, we will explore the most fascinating scenarios for the end of the universe: the Big Crunch, the Big Rip, heat death, vacuum decay. Each of them could bring the cosmos to its final chapter in a different way. But which one will happen? We still do not know. Imagine the universe continuing to expand forever. For billions and trillions of years, galaxies drift farther and farther apart. Stars burn through their fuel and eventually fade into cold, dark remnants. New stars stop forming because there is no fresh gas left to create them. The night sky grows emptier as more stars die, leaving behind only the faint glow of ancient light. In a big freeze scenario, the expansion of the universe never slows down. Gravity cannot pull everything back together. Instead, space stretches endlessly, and the temperature of the universe drops closer and closer to absolute zero. At that temperature, motion nearly stops, and no energy is available to sustain any form of life or activity. Even the most stable stars will eventually burn out, leaving behind white dwarfs, neutron stars, and black holes. Over unimaginable timescales, those black holes will slowly evaporate through Hawking radiation, leaving only subatomic particles scattered across a vast, dark universe. From a human perspective, this end is quiet and lonely. There is no explosion, no sudden disaster, just an endless fading of light and heat until the universe becomes a cold, dark, and silent place. The Big Crunch is the opposite of the Big Freeze. Instead of expanding forever, the universe would eventually slow down and start contracting. Galaxies would stop moving apart and begin falling back toward each other. Over billions of years, gravity would pull everything closer, making the universe denser and hotter as the collapse continues. Galaxies merge, stars are torn apart, and temperatures rise to unimaginable levels. The night sky would grow brighter, not darker. As all matter and energy are squeezed into a smaller and smaller space, in the final moments, the entire universe could be crushed into a single, incredibly dense point. This state might be similar to the conditions at the beginning of the universe before the Big Bang. Some scientists have even speculated that a Big Crunch could trigger another Big Bang, leading to a new universe being born. In this view, the cosmos might be part of an endless cycle of expansion and collapse. The Big Rip is one of the most dramatic endings the universe could face. In this scenario, a mysterious force called dark energy does not remain constant. Instead, it grows stronger over time. Dark energy is already making the universe expand faster and faster. But if its power increases without limit, it could eventually overcome every other force in the universe. First, galaxies would be torn apart as the space between them stretches too quickly. Then, the same process would break apart star systems, pulling stars away from planets. Even planets themselves would be ripped apart as the expansion overpowers gravity and the bonds between atoms in the final moments. The very fabric of space and time would expand so violently that atoms, protons, and even subatomic particles could be destroyed. The universe would end in a burst of unstoppable expansion, leaving nothing behind but a cold, empty void. Vacuum decay is a strange and terrifying idea from quantum physics. It starts with the possibility that our universe is not in its most stable form. Instead, we might be living in what scientists call a false vacuum. In this state, the universe appears stable, but deep down, it is only temporarily balanced. One day, a random quantum event could trigger a shift to the true vacuum state. This change would create a bubble of true vacuum that expands at the speed of light. Anything inside this bubble would instantly be destroyed. As the laws of physics themselves would change, there would be no warning, no escape, and no way to stop it. Because the bubble travels at light speed, we would not even see it coming. One moment everything would be normal, and the next moment the universe as we know it would be gone forever. Heat death is considered by many scientists to be the most likely end for our universe. It is based on the second law of thermodynamics, which says that over time, energy becomes more and more evenly spread out. In the distant future, stars will burn out, galaxies will grow dark, and black holes will slowly evaporate. As this happens, the universe will move toward maximum entropy, a state where there are no differences in temperature or usable energy anywhere. Without energy differences, no physical processes can occur. No stars can shine. No life can exist. The universe would be cold, dark, and silent, filled only with thin clouds of particles drifting endlessly. This process would take an unimaginable amount of time. We are talking about numbers so huge that they almost have no meaning to us. But in the end, all that would remain is a vast, empty space, forever still. The ultimate fate of the universe is still unknown. Theory: Big Freeze, Big Crunch, Big Rip, Vacuum Decay, and heat death is based on our best scientific understanding, but none are certain. Future discoveries about dark matter, dark energy, and the fundamental laws of physics could change everything. We think we know. What is certain is that our universe is constantly evolving. From the Big Bang to the present day, it has been a story of change, growth, and transformation. Whatever its end may be, the universe's journey is as fascinating as its possible destinies. And for now, we're here, able to explore it, study it, and marvel at its beauty.